The National Electrical Code permits the use of 12/3 wire in residential branch circuits, including those supplying air conditioning units. However, there are specific requirements that must be followed to ensure safety and compliance. One key consideration is ampacity derating. When more than 3 current-carrying conductors are bundled together in a conduit or raceway, the ampacity of the wire must be reduced. For 12/3 wire, the ampacity is typically derated to 20 amps when 4 or more conductors are present in a bundle. It's important to understand why this derating is necessary. When conductors are bundled together, they generate heat. If the heat cannot dissipate effectively, the conductors can overheat, potentially leading to insulation damage, electrical fires, or other hazards. Derating the ampacity ensures that the conductors operate within their safe temperature limits. In the scenario of using 12/3 wire to supply air conditioning units, this derating rule applies if the conductors are bundled with other current-carrying conductors. You must ensure that the air conditioning units do not draw more than 20 amps when operating. Overloading the circuit can create a dangerous situation. Another crucial requirement of the National Electrical Code is that all conductors in a branch circuit must be of the same gauge. This means that if you start with 12/3 wire, you must continue using 12/3 wire throughout the entire circuit. You cannot switch to 12/2 wire for a portion of the circuit. The reason for this requirement is to maintain consistent ampacity and prevent imbalances in the circuit. Using different wire gauges can lead to some segments of the wire overheating while others are underutilized, potentially causing a fire hazard. Now let's consider the specific situation of wiring 2 air conditioning units. If you are using 12/3 wire from the panel to the first air conditioning outlet and then want to use 12/2 wire to connect to the second air conditioning unit, this is not permitted by the National Electrical Code. You must use 12/3 wire for the entire circuit to maintain a consistent wire gauge. Furthermore, it is important to verify that the total load of both air conditioning units does not exceed the derated ampacity of the 12/3 wire, which is 20 amps. If the combined load exceeds 20 amps, you would need to use a larger gauge wire or split the load between multiple circuits. It's also worth noting the color coding of the wires within a 12/3 cable. Typically, a 12/3 cable contains a black wire, a red wire, a white wire, and a bare copper ground wire. The black and red wires are the hot wires, the white wire is the neutral wire, and the bare copper wire is the ground wire. When wiring an outlet, it is essential to connect the wires to the correct terminals. The black wire goes to the brass terminal, the white wire goes to the silver terminal, and the ground wire goes to the green terminal. Using the correct wiring configuration ensures proper circuit operation and reduces the risk of electrical shock. When installing wiring, always follow safe electrical practices. Firstly, always turn off the power to the circuit before working on it. Use a voltage tester to confirm that the circuit is de-energized. Secondly, wear appropriate personal protective equipment, such as safety glasses and gloves. Thirdly, carefully strip the insulation from the wires, being careful not to nick or damage the conductors. Fourthly, make sure that all connections are tight and secure. These connections can cause overheating and arcing, leading to electrical fires. Fifthly, properly secure the wiring in the electrical boxes and prevent it from being pinched or damaged. Sixthly, use cable staples to support the wiring along its run. Seventhly, do not overload circuits with too many devices. Eighthly, use correctly rated breakers to protect the wiring from overcurrents. Ninthly, label all circuits clearly in the electrical panel. Tenthly, test all circuits after installation to ensure that they are working correctly. Always remember that electrical work can be dangerous if not done correctly. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. An electrician has the knowledge, skills, and experience to ensure that the electrical system is installed safely and in accordance with the National Electrical Code. Keep in mind that the National Electrical Code is not a static document. It is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date with the latest version of the National Electrical Code to ensure that your electrical work is compliant. In addition to the National Electrical Code, local jurisdictions may have their own electrical codes and regulations. These local codes may be more stringent than the National Electrical Code. It is essential to consult with your local building inspector to determine the specific requirements for your project. Building inspectors are responsible for enforcing electrical codes and ensuring that electrical work is done safely. They can provide valuable guidance and help you avoid costly mistakes. When planning an electrical project, start by creating a detailed plan that outlines the scope of the work, the materials needed, and the wiring layout. This plan will help you stay organized and ensure that you do not miss any important details. Obtain the necessary permits before starting any electrical work. Permits are required for most electrical projects to ensure that the work is inspected and meets code requirements. When selecting electrical components such as outlets, switches, and circuit breakers, make sure that they are rated for the intended use. Using the wrong components can create a safety hazard. When running wiring through walls or ceilings, use appropriate wiring methods to protect the wiring from damage. This may include using conduit or cable trace. Be sure to properly ground all electrical equipment. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Regularly inspect your electrical system for any signs of damage or wear. Replace any damaged components immediately. If you notice any unusual smells, noises, or flickering lights, investigate the cause and take corrective action. Ignoring these warning signs can lead to more serious problems. Never attempt to repair electrical equipment if you are not qualified to do so. Always hire a qualified electrician to perform electrical repairs. Electricity is a powerful force that can be dangerous if not handled properly. By following safe electrical practices and consulting with qualified professionals, you can ensure that your electrical system is safe and reliable. Remember that safety should always be your top priority when working with electricity. By taking the necessary precautions, you can protect yourself and your property from electrical hazards. In the specific scenario mentioned, where you are using 12/3 wire from the panel to one air conditioning outlet and then want to use 12/2 wire to the next one, it is crucial to understand why this is not recommended, despite the intention to save wire. The electrical code emphasizes uniformity and safety within a circuit. Firstly, using 12/3 wire initially provides a certain ampacity rating and grounding configuration. Secondly, switching to 12/2 wire introduces a potential mismatch in ampacity and grounding, disrupting the intended protection and potentially overloading the thinner wire. Thirdly, the code requires a consistent gauge throughout the circuit to ensure that the overcurrent protection device, like a circuit breaker, can properly protect the entire run of wire. Fourthly, inconsistent wire gauges can lead to uneven heating and potential hotspots, increasing the risk of fire. Fifthly, while the intention to save wire is understandable, the potential safety risks and code violations outweigh the minor cost savings. It's always better to prioritize safety and compliance by using the correct wiring methods and materials, even if it means using a bit more wire. Also, remember to consider voltage drop, especially over longer distances. While 12-gauge wire is generally suitable for 20 amp circuits, voltage drop can become an issue if the wire run is excessively long. Voltage drop occurs when the voltage at the end of the circuit is lower than the voltage at the source. This can cause appliances to operate inefficiently and can even damage them. To minimize voltage drop, you may need to use a larger gauge wire or shorten the circuit run. You can use voltage drop calculators available online to determine the appropriate wire size for your application. Furthermore, when working with electrical panels, it's crucial to maintain proper clearances and follow all safety guidelines. Electrical panels can contain live parts that can be extremely dangerous if touched. Always wear appropriate personal protective equipment such as safety glasses and gloves when working near electrical panels. Never reach into an electrical panel without first turning off the power. Use a voltage tester to confirm that the panel is de-energized before touching any components. Keep the area around electrical panels clear of obstructions. This will allow for easy access in case of an emergency. Never store flammable materials near electrical panels. Flammable materials can ignite if exposed to sparks or heat from the electrical panel. And finally, remember to properly label all circuits in the electrical panel. This will make it easier to identify and troubleshoot circuits in the future. Use a permanent marker to write the circuit description on the label. Be clear and concise in your descriptions. Update the labels whenever you make changes to the electrical system. In summary, while using 12/3 wire for air conditioning circuits is permitted under the National Electrical Code, strict adherence to ampacity, derating, consistent wire gauge, and local code requirements is essential. Always prioritize safety and consult with qualified professionals to ensure compliance and prevent potential hazards.